Hi everyone. Okay, I found this and I had no idea that scientists wanted to make an artificial sun on Earth. Okay, this was posted in 2008. It turns out that it's called uh, the National Ignition Facility in Livermore, California. And they want to create this sun. It's been going since 1999. So at 2008, in the spring of 2009, they were going to do their experiment, which is to trigger a nuclear, thermonuclear um, event to try to create a sun. Okay, I'm going to read this because it's really fascinating, and it's to help create a new energy source. So maybe that's why people are seeing all these suns and lights in the sky, and they're hiding things, and then sometimes it looks like a fake sun, and sometimes it looks like a real sun. Who knows? Okay, so I guess this is it. It's huge. Well, it's a bunch of football fields big. Anyway, it says, while it has seemed an impossible goal for nearly 100 years, scientists now believe they are on the brink of cracking one of the biggest problems in physics by harnessing the power of nuclear fusion, the reaction that burns at the heart of the sun. Well, some people think the sun is electric. Anyway, I don't know, but have you heard of this before? I never heard that scientists wanted to create an artificial sun. How could I have missed this? In the spring, a team will, remember this is written in 2008, in the spring a team will begin attempts to ignite a tiny man-made star inside a laboratory and trigger a thermonuclear reaction. Oh my gosh, this sounds mad. Its goal is to generate temperatures of more than 100 million degrees Celsius pressures pressures billions of times higher than those found anywhere else on Earth, from a speck of fuel a little bigger than a pinhead. If successful, the experiment will mark the first step towards building a practical nuclear fusion power station and a source of almost limitless energy. At a time when fossil fuel supplies are dwindling and fears about global warming are forcing governments to seek clean energy sources, fusion could provide the answer. Hydrogen, the fuel needed for fusion reactions, is among the most abundant in the universe. Building work on the 1.2 billion pound nuclear fusion experiment is due to be completed in the spring. Oh, they're going to finish it in the spring, 2009. Scientists at the National Ignition Facility in Livermore, and you can take tours there if you want. You have to apply. Nestled among the wine-producing vineyards of Central California, will use a laser that concentrates 1,000 times the electric generating power of the United States into a billionth of a second. I can't even really comprehend these numbers. The result should be an explosion in the 32-foot wide reaction chamber, which will produce at least 10 times the amount of energy used to create it. We are creating the conditions that exist inside the sun, said Ed Moses, director of the facility. It is like tapping into the real solar energy, as fusion is the source of all energy in the world. It is really exciting physics, but beyond that, there are huge social, economic, and global problems that it can help to solve. All right, blowing up the world would solve a lot of problems. Inside a structure covering an area the size of 3 football pitches, a single infrared laser will be sent through almost a mile of lenses, mirrors, and amplifiers to create a beam more than 10 billion times more powerful than a household light bulb. Housed within a hangar-sized room that has to be pumped clear of dust to prevent impurities getting into the beam, the laser will then be split into 192 separate beams, converted into ultraviolet light, and focused into a capsule at the center of an aluminum and concrete-coated target chamber. Hmm. When the laser beams hit the inside of the capsule, they should generate high-energy X-rays that, within a few billionths of a second, compress the fuel pellet inside until its outer shell blows off. This explosion of the fuel pellet shell produces an equal and opposite reaction that compresses the fuel itself together until nuclear fusion begins, releasing vast amounts of energy. Oh my gosh. Scientists have been attempting to harness nuclear fusion since Albert Einstein's equation E equals mc squared, which he derived in 1905, raised the possibility that fusing atoms together could release tremendous amounts of energy. Under Einstein's theory, the amount of energy locked up in 1 gram of matter is enough to power 28,500 100-watt light bulbs for a year. Until now, such fusion has only been possible inside nuclear weapons and highly unstable plasmas created in incredibly strong magnetic fields. The work at Livermore could change all this. Okay, now remember this is written in 2008, and it was projected to be finished in spring of 2009. And they had to create a lot of some things didn't exist that they needed, and they had to create it. All right, a little farther. The sense of excitement at the facility is clear. In the city itself, people on the street are speaking about the experiment and what it could bring them. Until now, Livermore has had only dubious honor of being home of the U.S. government's nuclear weapons research laboratories, which are on the same site as the NIF. The NIF, which is the National Ignition Facility. Inside the facility, the scientists are impatient. After 11 years of development work, they want the last of the lenses and mirrors for the laser to be put in place and the tedious task of adjusting and aiming the laser to be over. A process they fear could take up to a year before they can successfully achieve fusion. Jeff Wisoff, a former astronaut who is Deputy Principal Associate Director of Science at the NIF, said, "Everyone is keen to get started, but we have to get the targeting right, otherwise it won't work." Okay. We will be firing laser pulses that last just a few billionths of a second, but we will be creating conditions that are found in the interior of stars or exploding nuclear weapons. Oh my gosh, do they know what they're doing, or what risk they're putting us into? I worked on the building of the International Space Station, but this is a far bigger challenge and the implications are huge. When we started the project, a lot of the technology we needed did not exist, so we've had to develop it ourselves, as I was saying. The next step is looking at how ignition can be used to deliver something of value to the world, if we don't blow it up first. Oh, I interjected that. It has the potential to be one of the biggest achievements mankind has made. And then put this together with all the other experiments that people are doing, scientists in other parts of the world, China, India, all those places that are doing earthquakes and clouds, and this is getting crazy, isn't it? Although other experiments have attempted to create the conditions needed for nuclear fusion, lasers are seen as the most likely technique to be able to provide a viable electricity supply. If all goes well, the NIF will be able to fire its laser and ignite a fusion reaction every 5 hours. But to create a reliable fusion power plant, the laser would need to ignite fusion around 10 times a second. Okay, a little bit more. Oops. All right, I've lost my place. All right, down here. The scientists are already working with British counterparts on the next step towards a fusion power station. A project known as the High-Powered Laser Research Facility aims to create a laser-powered fusion reactor that can fire once every couple of minutes. Alright, so you can read about this, and so this person who put this together, first it was fear of the Earth being swallowed by a black hole by the Large Hadron Collider, and now this. I don't have any real opinions of this yet. I just hope whatever they are doing works out. Yeah, me too. Okay, and then here is a list of the National Ignition Facility, and you can type that in and go find it and read some things. They're going to trigger a thermonuclear reaction. They want to create their own star, another sun on Earth. And energy of the future, igniting a star with laser light. Remember, they're recreating the inside of a star, the inside of the sun. So you can find the most up-to-date one. I thought this was kind of interesting. $5 billion over its original budget and years behind schedule, the National Ignition Facility deserves to be recognized as perhaps the biggest and fattest white elephant of all time. Maybe this is why we're seeing these lights in the sky. You know, fluorescent sky, bright sun spots, red. The sky is red and boiling. Who knows? All right. Thank you for listening, and take care. God bless everyone.